In this assessment, we're asked to predict the product of the reaction of the cis-diol with periodic acid. This reaction is going to start by forming a periodate ester. Let's draw that. First, we have to sketch our 7-membered ring. Not always the easiest ring to draw. Put our methyl group here. And the periodate ester that we're going to make will look like this. So 3 hydroxyl groups and 1 double bond coming off. All of these reactions will go through this intermediate, and the fact that this intermediate has to form is the reason that 2 hydroxyl groups need to be at least able to be positioned on the same side of the ring, or in the case of an acyclic system, be able to rotate around so that we can make this. Once here, we're going to have a 6-electron cyclic transition state that looks like this, where these electrons are going to come down, these are going to go here, and these go on to the iodine. This iodide is pulling this electron density and is what's getting reduced in the process. If we follow those electrons around and follow those arrows and draw what we get, it may be helpful here to number the carbons to see what our chain is going to look like. Because if we break this bond, it's no longer going to be a ring. So let's number our carbons to see that we need it to be an 8-carbon chain. We can now just sketch our 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Carbon 1 is a methyl. Carbon 2 is going to have a new carbon-oxygen double bond. Keep going around. 3 is a CH2, as is 4, as is 5, 6, 7, 8 is going to have another carbon-oxygen double bond. So this is carbon 8. By numbering the carbons, we see that this is the acyclic version of the product of this reaction. So when we break this bond here, it goes from being a ring to no longer being a ring. Here is the product of this reaction.